Module 9, Lesson 2 covers the surface area of rectangular prisms. This is going to require a little bit more work than the easy method of finding the volume of rectangular prisms, but none of the work's really hard. It's just a lot to cover. So let's get started on doing this. The pacing guide says this is going to be one long stinking lesson at 135 minutes. They claim that's 3 days. I don't know if it'll take us 3 days to cover 11 slides. We'll find out how long it takes. Have you ever wrapped a gift for someone and found you didn't have quite enough wrapping paper? Rolls of gift wrap come in different sizes. The label might not always give you the dimensions of the paper, but it will always tell you the square footage the paper will cover. Now, I'm actually making this video on New Year's Day, sitting in my classroom all alone. It's sad, I know, but I just got done wrapping Christmas presents not that long ago, and they are indeed right. The wrapper does tell you how many square feet of wrapping paper there are in each roll. Question is, how can you use the square footage on a package to determine whether or not you have enough gift wrap to wrap the box? Well, you could do a whole lot of math, or you could do what I do. You try and cover it, and then you realize, well, crud, I don't have enough wrapping paper. Dang it. Let's keep moving. Now, this Explorer we're going to look at is going to help us to visualize a three-dimensional figure. So, moving over to the first tab, it says a prism can be unfolded or unwrapped to form what is called a net. Now, a net is a very important term. I'm not sure if they're actually going to define it or whatnot, but the simple way of saying it is you get that pizza box in. When you lay that pizza box all out flat, you've created a net of that pizza box. You've unfolded the box. That's what we're looking at doing here. Because, let's see here, the net is like a map of the figure showing the location of the bases and the faces. A cube is going to be a special type of rectangular prism with 6 congruent faces. Every side of that cube is going to be the same exact size. Because the basis and the, it says right here, because the basis and the faces are all the same, it can be difficult sometimes to tell the faces apart when you're dealing with a cube. So we're going to take and drag the endpoints to spin, pitch, and roll controls, and notice how the cube moves and rotates in different directions. And then rotate the cube and observe the letters. So in doing that, we can roll our cube like this. Wow, that was exciting. We can pitch it like that and see tops and bottoms and whatnot, and we can spin it like that. Surely there's a way that I can see. I just saw a hint of an F there. How do I get to that F? There's the F. Yep, so you got all 6 sides of that cube. The point of that, I don't know, but there are 6 sides to it. Now it says label the correct face of the net with the letter C. Explain how you can tell which one is going to be letter C. Well, we can see that A and B come together right here, and C is going to be a point where A and B come together. So in reality, C could technically be one of 2 different sides. C could be, let's see, how do I do it? Oh, it says a copy on a separate sheet of paper. C could be this side right here, where when you took and folded it back up, this piece here would match that. Or C could be that spot there. Once again, when you fold that net back up, then this piece would be touching both the A and the B. The textbook ended up claiming that this was side C, and if you watch as they wrap this, it's actually pretty dang cool. It's going to come and everything lines up, and you can see how that side ended up being C, this folded down to be B, and it ended up wrapping our box quite nicely. So right there, this spot here was C. If you chose where the D is for C, that could have worked as well. And of course, those sides are coming from, you can see an F right there. You can see D over here next to E. So you got all those different sides that would end up rolling up to wrap up and cover that whole entire box. Really pretty darn cool how that works. Now, a net here is given as definition we talked about earlier, is a 2-dimensional representation of a 3-dimensional figure. Go ahead and highlight that in green. When you construct a net, you are deconstructing the three-dimensional figure using its two-dimensional faces. A rectangular prism is going to have 6 rectangular faces. The top and bottom faces are going to be congruent, the front and back faces are going to be congruent, and the two sides are going to be congruent. And you can see right here how they unfolded that rectangular prism in order to get the net. Give it a second, it's going to do it again. Here we go. It's going to unfold itself. And now, boom, there you have a net of the rectangular prism that is given. Some things to notice: your top and your bottom are going to be congruent or the same size. The back and the front, those are going to be congruent as well, the same size. And your two sides, those two are going to be congruent or the same size. Now, example 1 gives us a rectangular prism that has a length of 10 centimeters, a width of 6 centimeters, and a height of 8 centimeters. And they want you to draw and label a net to represent the rectangular prism. Let's see if they give us some cool technology to do this with. Move through the steps, make the net of the rectangular prism, draw and label the front face, the side faces, and use grid paper. Let each grid equal 1 centimeter. The front of the prism and one side are given. What are the dimensions of the front centimeter? It's going to be the front right here. It's going to be, let's see, 8 centimeters tall because it's the same as that, and 10 centimeters long. So we have 8 and we have 10. And then the side is going to be 8 centimeters tall and 6 centimeters wide. So I'm going to have an 8 and a 6. And from there, we can take and check that. And that part ended up checking. Zoom out just a little so we can see it. All right, so you can see we have one side and we have a front. Next, from there, we have another side, which is going to be the same size as this one right here. So it's going to be a side length. That's going to check. Next thing we're going to do, we have the front. We need to take and, oh wait, what are the dimensions of the highlighted face? Well, the side is going to be the same as this. So it's going to be 8 tall and 6 wide, and that checks. Next, we're going to take and add to the top and the bottom right here. And from the top and the bottom, check that. And it's going to check, of course. And then what are the dimensions of the top and the bottom going to be? Well, the length here, that's going to be the same as the length of the front, which is going to be 10. And this side length here, that's going to be the same as this side length right here, which is going to be 6. Check that, and that part checks. Now all we have to do is add the back of the box to it, which is right here. That represents the back of the box. And what are the dimensions of the back of that box going to be? Well, the length is going to be the same here, which is going to be 10. And the height is the same here, which is going to match that, which is going to be 8. And it checks again. So right there, we've made ourselves a net of that rectangular prism and labeled all the side lengths. You have to label your side lengths on the net as you're making it. You can't just draw the box. Now it's going to be your turn. You have extra example 1 right here. Work through it and figure out which one of these drawings represents a net of that rectangular prism. Go ahead. All right, going through this, first one right here, option A, shows the front and the back sitting right next to each other. That can't be. They've got to have another space between them, so A is not going to be the correct answer. Next, we have a top and a bottom opposite of each other, a front and a back opposite each other, and a side and a side opposite each other. So that would be a valid net, assuming the side lengths are correct, which I believe they are. Yep. And, yep, everything looks good. 3, 2, yep, everything's good there. And then for this one right here, well, would these two sides fold up to match what they have here? No, it won't. So even though the top and bottom are opposite each other with the back and the front between them, it's not going to fold up right. It just won't fold back in to make a box. So the correct answer you should have selected is going to be B for that problem. The surface area of a rectangular prism is going to be the sum of the areas of its faces. So we've learned how to make a net. Now we have to take and find the area of each one of those sides of that net and add them all up together to find the surface area of the entire figure. And we have a video on how to do that.
Use nets to find surface of rectangular prisms. One way to find the surface area of rectangular prisms is to use a net. A net is a two-dimensional pattern that can be used to build a three-dimensional figure. Open the prism and use a marker to label the rectangular top, bottom, front, back, side 1, and side 2. Measure the length and width of each face and then calculate the area beginning at the top. 3 inches by 2 inches. Write the dimensions and calculate the area, 6 square inches. Opposite faces of a rectangular prism have the same dimensions, so they are congruent. The bottom face will have the same area as the top face, 3 inches by 2 inches. Write down the dimensions. Now, measure the front face and write down the dimensions. 3 inches by 4 inches. The area is 12 square inches. The back face will have the same dimensions as the front. Measure side 1, 2 inches by 4 inches. The area is 8 square inches. Side 2 will have the same dimensions as side 1. Now that the area has been calculated for each face, calculate the sum of the areas. The surface area of the rectangular prism is 52 square inches.
That's a really good way to do it. Only thing I would really do difference is I would include my formula, area is equal to length times width, or area is equal to base times height. For example 2, John is covering the faces of a gift box with wrapping paper. Now he's doing exact matches on all sides of the wrapping paper. He's not wrapping like you and I wrap. He's doing perfect, not wasting any paper wrapping. So, use a net to determine the minimum amount of wrapping paper that John's going to need to be able to wrap this present. And you can see right here he's unfolded his box. He has created his net to where he's got a total of 6 sides. 2 of the sides are going to be 10 centimeters by 6 centimeters. That's this side and this side. 2 of them are going to be 8 centimeters by 6 centimeters. That's this one and this one. And 2 of them are going to be 8 centimeters by, and what would that match? It would match the 10 centimeter side here, and that's going to be this one and this one right here. So in order to find the total surface area, what we have to do is find the area of each one of those sides. Working through it, since the corresponding faces are congruent, we can take and multiply the areas of one face by 2 to find the area of each of the pairs. I don't really like that, so instead of doing that, let's just take and make a screenshot of that and let's work it out together. So I'm going to take and get my screenshot, throw it down on my paper right here, make it a little bigger so we can see something to work with, and then we're just going to start working through this. Now the formula I'm going to be using says that area is equal to base times height, also known as area is equal to length times width. And the first one I'm going to do is this one right here. So I'm going to take and say area is equal to, I have a base of 6 times a height of 8. Area is equal to, what's 6 times 8? It's going to be 48. So this one here is going to be 48, and this one here is going to be 48 because they're the same exact size. Next, I'm going to box off that supporting work, and I'm going to do this rectangle right here. So I'm going to start off with my formula. Area is equal to base times height. Area is going to equal to, the base is going to be 10, the height is going to be 6. So the area of that one is going to be 60, and that applies to this one and to this one that's on the opposite of it. Box off that supporting work and do the last pair of rectangles. Area is equal to base times height is my formula, which I have to write every time. Then I'm going to say area is equal to, the base is 10, the height is 8, so I'm going to have 10 times 8, otherwise known as 80. So I can write an 80 here, and I can write an 80 here. Finally, what do I have to do? I have to add them all up. So I have two 80s, an 80 and an 80. I have two 60s, a 60 and a 60, and I have two 48s, a 48 and a 48. And I'm going to add all those up together. That's going to give me a 16, carry the 1. Let's see here. That's going to give me 20, 36, 37. If I did that right in my head, it's going to end up, yeah, I know my spacing's bad, being 376 inches squared. Jump back over to what the textbook had said when they did it. They took and added them all up, and let's type in our 376 right here, check it, and the answer checked. Now they did some times twos in there and whatnot, but that's not really the way I would want to do it. Go back, look at what they did. They took and zoom out here. They found the side length, the areas of the front. They found the areas of the back, of the sides, and the areas of the top and bottom using a good formula. So they did have good supporting work there. And then instead of adding them, they multiplied the front and back times 2, the top and bottom by 2, and the sides by 2, and then added those up to get to the same answer that I got. It works. My way works better. My way is what I want to see coming out of you. Now it's going to be your turn. Pause the video. Solve this problem on your own. Find its surface area. As an added bonus, I'll let you use a calculator to find the individual area of each rectangle. How'd you do? When I work the problem, I recognize I've got 3 rectangles I have to actually find the area of, and I'm going to go ahead and do some coloring here. We're going to say A and B are going to be the same size. I'm going to say that C and D are going to be the same size, and I'm going to say that E and F are going to be the same size. So starting with rectangle A, you can use base times height, or you can use length times width like the textbook did. With base times height, I'm going to have a base of 1.5 times a height of 1.2, which means, by our calculator over here, that we're going to have a 1.5 times 1.2, which is going to give us an area of 1.8. Let me make sure I type that in right. 1.5 times 1.2. Yep, that's good. So I can write 1.8 here and 1.8 there. Next, box that off, and let's find the area of the blue triangles, the rectangles. So area is equal to base times height again. Area is equal to, the base is going to be 1.2, and the height is going to be, this distance right here, which is the same as that distance right there, which is 1.2 again. That means, I believe it's going to be 1.44, but let's see, 1.2 times 1.2 equals, how about that? 1.44, which we can take, and we can circle each of these when we finish them up. 1.44 and 1.44. Finally, we're going to do the green, which has area is equal to base times height. Area is equal to, the base is going to be 1.5. This one right here, the height right there is 1.2. And that, incidentally, is going to be the same as these that we did up here. It's just kind of backwards with how it was laid out. So area is going to equal to, once again, 1.8, which belongs to that one and to that one. Finally, all that's left to do is add them up. So I have 1.44, 1.44, 1.80, 1.80, 1.80, and 1.80. And we're going to add those up. 4 plus 4 is equal to 8. And here I've got 1, 2, 3, 4 8s. 8 times 4 is going to give me 32. plus 4 is going to give me 36. Plus 4 is going to give me 40. So I'm going to put in a 0 and carry the 4. And then I'm going to add these up. 4, 5, 6, 7, 8, 9, 10. And then that decimal comes down. So the area of the entire shape is going to be 10 and 800ths, which we're going to jump back over here and plug in our in 10.08. Check your answer, and your answer checks. This is showing your work. That is what I must see if you want credit for it. Get busy doing your homework. I'll see you in class tomorrow to answer any questions you have.